Namaste and hi. Today we are going to learn about the history of the Cartesian plane and where we use it in real life. Imagine trying to meet a friend in a huge ancient city without a mobile phone or Google Maps. How would you tell them your exact location?
Hmm, I'm completely lost. Which way to his house?
This is where the idea of coordinate becomes important. Coordinates are not just a mathematics topic in a textbook. They are an idea developed over thousands of years to solve real life problems like building cities, traveling, finding directions, and studying stars. Thousands of years ago, in the Sindhu Saraswati civilization, cities were built using grid patterns. Roads were planned in a straight lines going north south and east west. This helped people find places easily. This was one of the earliest examples of grid based thinking. Later, around 800 BCE, the Indian sage Baudhayana used north south and east west lines in geometry. His ideas helped in advanced geometry construction. As traveling and navigation became important, people needed a central reference point to measure locations. In ancient India, Ujjaini was used as an important reference point, almost like a starting line for measuring positions. Around 499 CE, the great mathematician and astronomer Aryabhatta improved calculations by using signs. This made it easier to find the positions of stars and planets in the sky. Later, Brahmagupta introduced the use of zero and negative numbers, which become very important in mathematics and coordinate geometry. Indian mathematical ideas spread to Arab scholars. They translated Brahmagupta's work and used these ideas in maps, astronomy, and mathematics. Finally, in 1637, the French mathematician René Descartes developed the Cartesian plane, the system we use today. He showed that any point can be located using two numbers ordered pair xy with the help of two lines called x-axis and y-axis.
Can you guess where we use the Cartesian plane? We use the Cartesian plane in Google Maps, GPS, games, engineering, architecture, computer graphics, and even in astronomy.
Here you can see a Cartesian plane. The horizontal line is called the x-axis and the vertical line is called the y-axis. These two lines meet at a point called the origin, represented by capital letter O. The coordinates of the origin are always ordered pair 0, 0. Now look carefully at the Cartesian plane. The x-axis and y-axis divide the plane into four parts called quadrants. The top right part is called quadrant 1. Here both x and y are positive. The top left part is called quadrant 2. Here x is negative and y is positive. The bottom left is called quadrant 3. Here both x and y are negative. And the bottom right part is called quadrant 4. Here x is positive and y is negative. To remember the order of quadrants, move in an anti-clockwise direction starting from quadrant 1. Now let us see how to locate a point on the Cartesian plane. Here we have a point P of xy. To find the position of this point, we first look at the x coordinate. Move along the x-axis horizontally. Here the x value is positive 4. Next we look at the y coordinate. Move vertically parallel to y-axis. Here the y value is about positive 2.5. So the coordinate of the point P are written as P of 4, 2.5. Since both x and y are positive, the point lies in the first quadrant. Now let us understand an important idea in coordinate geometry. The order of coordinates matters. In the first example, x equal to y. Here the point is 2, 2, ordered pair 2, 2. If we change the order and write it as ordered pair 2, 2, it still remains the same point because both numbers are equal. So, when x and y are the same, ordered pair xy and ordered pair yx represent the same location. But in the second example, x is not equal to y. Look at the point ordered pair 3, 1. Here, x equal to 3 and y equal to 1. If we change the order, it becomes ordered pair 1, 3. Now the location changes completely because first we move along x-axis and then along y-axis. So ordered pair 3, 1 and ordered pair 1, 3 are different points. This means the order of coordinates is very important in a Cartesian plane. Now we are going to learn how to find the distance between two points A and B. Suppose we have 2 points A of x1, y1 and B of x2, y2. We want to find the distance between these 2 points. First look at the horizontal distance. We find the difference between the x values, which is x2 minus x1. Next, look at the vertical distance. We find the difference between the y values, which is y2 minus y1. Now, if we connect the 2 points, we get a right angle triangle. Since it is a right angle triangle, we can use the Pythagoras theorem. That is, hypotenuse square equal to base square plus altitude square. Here, the horizontal distance and vertical distance are the 2 shorter sides and the distance between A and B becomes the hypotenuse. So, the distance formula become d equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This formula helps us to find the exact distance between any 2 points on the Cartesian plane. For example, here we have 2 points A ordered pair 2, 3 and B ordered pair 6 minus 1. We need to find the distance between these 2 points. First, let us identify the coordinates. For point A, x1 equal to 2 and y1 equal to 3. For point B, x2 equal to 6 and y2 equal to minus 1. Now, we use the distance formula, that is d equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That is d equal to square root of 6 minus 2 the whole square plus minus 1 minus 3 the whole square. Therefore, d equal to square root of 4 square plus minus 4 the whole square. Now, d equal to square root of 16 plus 16, that is square root of 32 we will get, that is d equal to 4 root 2. So, the distance between A and B is 4 root 2. So, today we learned about the Cartesian plane and its interesting history. We understood what a Cartesian plane is, the x-axis and y-axis and the point where they meet called the origin. We also learned about the 4 quadrants, how to locate points, why the order of point matters and how to find the distance between 2 points using the distance formula.